In this video, we want to evaluate tangent of negative 510 degrees. So the first thing that we want to do is find our reference angle. And we could find our reference angle by drawing out the angle of rotation. That's an easy way to see the reference angle. So our initial side is right there, and we want to rotate clockwise because it's a negative angle. So we want to go down in negative 90, negative 180, negative 270, and then all the way to negative 360. Okay, we could keep going to negative 450, and then we could also keep going to negative 540, but we don't want to go that far. We want to stop at about negative 510, or not about, but we stop right there, and that's going to be our terminal side. So our reference angle is always the distance from our terminal side, which is right there, negative 510 degrees, to our nearest x-axis, and that's going to be negative 540 degrees. So we want the degrees from there to here, and that difference is 30 degrees. Okay, our reference angle is always going to be positive. So now we want to find the tangent of 30 degrees. Okay, so we need to pull up our special right triangle of 30, 30, 60, 90. So our right angle right there is 90. We'll say this is 30 and this is 60. It doesn't matter how you match it up, but across from 30 is 1, across from 60 is going to be the square root of 3, and then across from 90 is going to be 2. So now the tangent of 30, tangent is opposite over adjacent, so we want opposite side of 30 over the adjacent side of 30. So opposite of 30 of this degree, or I'm sorry, this angle right here, the opposite side is 1. So we write that down. And then the adjacent side of 30 is going to be the square root of 3. So I write that down there. Now that's good. We have 1 over the square root of 3, but we can't leave that radical in the denominator, so we have to rationalize it by multiplying it by the square root of 3 on top and on bottom. So we're going to be left with the square root of 3 on top, and then that's going to be divided by 3, because right here the square root of 3 times the square root of 3, that's going to be the square root of 9, which is just 3. So that's how we get that answer of 3 right there. Now tangent of 30 is the square root of 3 over 3. That's good, but now we have to go back to our original question. We want to evaluate tangent of negative 510 degrees. So the value, except for being positive or negative, we know that it's going to be the square root of 3 over 3. Okay, that was given when we found tangent of 30, but now we have to just decide whether this is going to be positive or negative. So we do that by calling up this cosine of theta comma sine of theta formula, or if you even want to call it a formula, but all of our ordered pairs on a coordinate system match up with this. So the x's are going to be with cosine of theta, and then sine of theta goes with the y's. So tangent of negative 512, you're like, well, that's not cosine or sine. Well, we do know that tangent of theta is equal to sine of theta over cosine, I got that right. Sine of theta over cosine of theta. So we could say, well, in the third quadrant here, that's what quadrant the terminal side is, and we know that sine is always going to be negative, and then cosine is also going to be negative. So if we have a negative divided by a negative, that actually equals a positive. Then we could kind of transfer that information over here. We know that our tangent of negative 510 degrees is going to be a positive square root of 3 over 3, and that will be our final answer. This could be a little tricky. It's an extra step trying to figure out the sine of tangent of theta, but just remember this formula right here. Sine had to be negative because any y values that are below the x-axis, like in the third quadrant, in the fourth quadrant, we're always going to have a negative for the y. But with cosine, we're matching that up with our values, or our signs of x's. And since the third quadrant is on the left side of the y-axis, we know that everything over here is going to be negative for x's. So that's why we have a negative down here as well for cosine of theta. And then we know a negative divided by a negative is going to be a positive. So that's how we make sure that this sign is correct for our original question. Okay.